Yesterday we looked at the review of expansion, and today we want to continue with it. We had already started with the Pascal triangle, which we said was developed by a French mathematician called Blaise Pascal. So we want to develop that, but we'll be using the mathematical table to be able to come up with it. So we say the expansion for, we should recall that a plus b to power 0, any number to power 0 in mathematics from the knowledge of indices gives us 1. We also say that a plus b power 1 gives us a plus b. If you multiply 1 times 1, you still get 1. 2 times 1, 2 to power 1, you still get 2. 3 to power 1, you still get 3. We also say that a plus b to power 2, we got an answer which was a squared plus 2ab plus b squared. We got also another one, a plus b cubed. The answer was a cubed plus 3a squared b plus 3a b squared plus b cubed. We also expanded a plus b to power 4, where the answer was a to power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to power 4. Now using this, we can be able to come up with a Pascal triangle where we have a plus b power 0, the coefficient is 1, a plus b to power 1, the coefficients are 1 and 1, a plus b squared, the coefficients are 1, 2, 1, a plus b to power 3, the coefficients are 1, 3, 3, 1, a plus b power 4, the coefficients are 1, 4, 6, 4, 1. We can be able now to get all the others using a pattern form here. If you look at the first one, we have said that the coefficient of any number to power 0 is 1. To be able to get the second one, we also said that it starts with 1 and ends with 1. So the third one, if you add 1 plus 1, you get 2. The third one, if you want to get it, starts with 1. To be able to get 3, you add 1 plus 2. 2 plus 1, you get 3, and you add with 1. 1 plus 3, you get 4. 3 plus 3, you get 6. 3 plus 1, you get 4. So you can be able to come up with all the others. The next one is supposed to be, you start with 1, 5, 10, 10, 5, 1. Can be able to get the next one, which is 1, 6, 15, 20, 15, 6, 1, and we can be able to get that. But instead of doing all that work, we have the binomial coefficients in the mathematical table. Our mathematical table seeks the addition. If you look at page 27, we have binomial expansion, which are given up to the power of 20. And you can be able to read them from there. So anytime now we're going to use that, and you can be able to use that during your calculations of binomial expansion. So now we want to use that. We want to get an example, and we'll start with example 1. Our first example is, we can start with the lowest that we did here, a plus b power 4. We want to expand that. Instead of doing the work that we did in the previous lesson, we can be able to use binomial expansion. So what do we need? We require the coefficients. You can go to the mathematical table and read the coefficients of power 4, which are 1, 4, 6, 4, 1. Those are the coefficients of 4. We have our terms. We want to expand that. Our first term is A and our second one is B. so we can be able to expand that. So we multiply a to power 4, and we move on like that, a to power 2, a to power 1, a to power 0. The second term is supposed to be, we start with the lowest power, which is b to power 0, b to power 1, b power 2, to power 3, to power 4, and we multiply them. If we multiply them, if we multiply 1 times a to power 4 times b to power 0, any number to power 0 is 1. So our first one will be a to power 4. The second one will be 4 times a cubed b, so it's going to be 4a cubed, 4a cubed b. The third one will be 6a squared b squared, which is 6a squared b squared. If we multiply the fourth one, we have a, 4 times a times b cubed, we have going to be 4a b cubed, and the last one will be b to power 4. So our expansion is going to be a to power 4 plus 4, here there is a plus sign which I forgot, right? 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to power 4. If you look at our previous answer, we got the same. So it is easier if you use the binomial expansion to expand rather than using the form 2 knowledge of expanding each term at a time. We go to example 2. Our example 2, we are going to expand 2x plus 3y power 4 again. We start by getting the coefficients. The coefficients of 4, again I've said you can get them from the mathematical table, are 1, 4, 6, 4, 1. We multiply with the terms. The first term is 2x and the second one is 3y. From the previous lesson we talked about that. 2x to power 4, that is our highest power. 2x to power 3, 2x to power 2, 2x power 1, and 2x power 0. So we multiply with this, 3y power 0, 3y power 1, 3y power 2, 3y cubed, 3y power 4. It's very, very important you put the bracket so that you are able to, the bracket there means you are multiplying, or you are multiplying everything that is inside the bracket with the power. So the first one will give us 2 to power 4 is 1 times 2 to power 4 times 3y to power 0 gives us 16x. The second one is 4 x to power 4. We have 16x to power 4. The second one gives us 4 times 8 times 3, which gives us, if you multiply using the calculator, 4, I can multiply it here, times 8 times 3 should give us 96 x cubed y. The third one, we have 6 times 2 squared, 4 times 3 squared, 9. If you multiply that one using the calculator again, you'll get 216 x squared, y squared. The third one, 4 times 2 times 3 y cubed gives us again 216 x y cubed. The last one gives us, if you multiply 3 to power 4 is 81. Then y to power 4 is y to power 4. So our answer is 16 x to power 4 plus 96 x cubed y plus 216 x squared y squared plus 216 xy cubed plus 81 y to power 4. Now, if you look at this, if you add the power of x and the power, because here there is 1, is to power 1, they should give us always to power 4. 2 plus 2, 4, 3 plus the power of x is 1, which is this one. So they should always add up to 4. That is how we are able to multiply using binomial expansion. We can go to, in our next lesson, we are going to continue with the same. We have dealt with a situation where we are only adding. In our next lesson, we shall deal with examples where we shall be subtracting. Wish you well. Bye.